Hey Math 8 students, so we're going to round off the year covering three tiny little topics. So we're going to cover something called transversals, which we already kind of explored a little bit with that explore it problem. We're just going to formalize it. So if you ever want to reference that, it'll be 6/8. And then we're also going to cover interior and exterior angles for triangles. And then lastly, and actually that'll be 6-9. And finally, we'll round off our year with something called angle-angle similarity. So we also want to know that we can understand if two triangles share the same or two identical angles, they got to be similar. So we're going to explore all three of these. And we're going to start off with that transversal concept. So kind of a big word, but you guys already did it with that solve it and discuss it problem I gave you on Friday to kind of just roughly explore this. So all a transversal is, and we're going to try to identify equal angles on it, is that you've got two parallel lines, and we can kind of mark these as parallel, the geometry notation like this. So if they have the equal amount of arrows, we know they are exactly parallel to each other, like train tracks. They go on forever and they never cross. And so there's going to be some basic properties of this. So all a transversal is, it's a line that comes in and just cuts through both. So it's a line that comes through and cuts through both lines. And if you try to find these in everyday life, if you just look out your window, look at a street, you'll find a lot of these. There's a lot of things in our society that goes with parallel lines, things cutting through it. If you just look out your window at kind of like a fence or like a roof of a house kind of slanting down, you'll find it intersects a lot of you'll find a lot of transversals. Also, if you look down on a map and you see like, oh, here's two roads, not all roads, even if they are exactly 90 degrees to it, you'll find a bunch of other like roads cutting through that you'll be able to find equal angles on. So we're going to explore this using like kind of some external software. So I'm going to switch over something called Geometry Sketchpad, and we're not going to do this on paper. We're going to do this a little bit more exact. So I'm going to start by constructing two parallel lines. So I'm going to start, we'll just make a line, say, this is one of our lines, and we'll say, let's make another point to it. So we're just going to construct parallel line through. So you can see if I rotate this line rotates with it, and they're exactly parallel, and I can just mark them as such. Oops, that's not what I want. Here we go. Let's do an arrow like that. So we know this one is parallel to that one. We'll kind of mark it. And we know that whenever I rotate this line, I rotate the other line as well. So now let's make our transversal. So remember we said the transversal just comes in and cuts through. We'll kind of mark the 2 points it intersects. So essentially what I have is I have 8 separate angles. We have the angle opening up here, 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 and then another 4 over here. So 1, 2, 3, 4 angles. And we're going to try to find which ones are equal. And as you can see, if I tweak this angle right here, this kind of moves along with it. And I can do this a little bit more exaggerated by going like this. So if I open up this angle here, I see that this one kind of opens up as well. And if I close this one off here, this one kind of follows suit. So we can just go through, kind of tweak it like that. And I could even measure these. So let's go through, let's make a formal measurement for this angle. Let's just have this software calculate it out really quick. So I'm just going to select my 3 points. We'll go ahead, measure that angle. We've named these points A, B, C, and it's measuring this angle. So you can see if I make it really shallow, it's going to go and specify that angle is really shallow. And if I make it and I kind of widen it out, you see right there, it's about at a right angle. It's saying 90 degrees. So I'm just measuring this angle right here. And let's try another one really quick. Let's try this angle here, see if there's any kind of relationship. So I can go through, select these 3 points. Let's go ahead, measure it. And you can see as I tweak this one right here, see this one shortening, no matter what I do with this transversal, these two angles stay equal. So let's go ahead and mark them. So I'll go ahead and take my angle tool, we'll mark here, and we'll just do one line to say those are equal. And we can make the same measurement here. So for instance, if I were to measure this angle opening up right here, we'll go ahead and measure it real quick. So bam, bam, bam. We measure that angle. Let's go to place it where it is. So it's just measuring this angle right here. You can see as I tweak it, all three kind of go with each other. So if I make this at 44.97 degrees, all the others follow suit. So we've got another matching angle. So these, we call them vertical angles. These are also, so these are corresponding or equal. These are also corresponding. So we got another set of equals. And you can see that we've got kind of the same relationship going on here, as well as here as well. So essentially, we've got this angle and this angle and this angle and this angle. They're all equal. And we also know that the measurement of this angle, this angle, this angle, and this angle are all equal. And no matter what I do, those angles will follow suit with each other. So if I make this one 90 degrees, this one is at 90 degrees. If I make this one at 90 degrees, these three other are at 90 degrees. So that's kind of your crash course into transversal. And I didn't mention this up front, but all of these you will explore in Math 10, which is essentially comes after algebra. This will be kind of just our crash course in it. So we've got identifying equal lines in a transversal, and we could even go back and say, well, we have a transversal. This line, or this angle and this angle are equal, which are also equal to these two angles, and separately, this angle is equal to this angle, which is equal to this angle, which is also equal to this angle. So a bunch of matching pairs that you can identify whenever you have this concept of a transversal cutting through two parallel lines. So now let's move on to another example. So interior and exterior angles of a triangle. So I'm going to go bring back up my Sketchpad software. We'll go ahead and take a look at that. So I can even go through and I can make a triangle within here. So actually let's just clear our stuff real quick. Oh, that'll be fine. So we'll go ahead and make another triangle. So what I'm going to do is I'm just going to make a point up here. And we'll go ahead and make a triangle. And I'm not going to extend it all the way out to this point. I'm going to make this line extend out a little bit. So I got this triangle I can manipulate. So what I'm going to do here is I'm going to label some things. So we'll take this angle here. Oops. And let's go ahead and make it 1 dash. Let's go ahead and label this angle here, and we'll label it with different markers to say that they're different angles. So if I were to do this, I would say this here, that is your interior angle. And let me go ahead and write that down really quick so we have it for reference. So let's see, get my pen tool up. Now we'll just label it this way. We got the interior angle, and we also have this exterior angle. So the key thing we're looking at here is I know the interior and exterior angle add up to 180. So we can look at this in two different ways. We can say, one, that if we look at this triangle and we look at the line that the interior and the exterior angle on, we can see that's essentially a straight line. So the whole thing opens up to 180 degrees. And let's just go through and prove it to ourselves. Let's measure it, and then let's go ahead and let's go ahead and just look at those angles. So we'll go ahead and clear everything real quick, and we'll go ahead and measure those. So let's measure this inside angle here. We'll just select our 3 points. We'll go ahead and measure that angle. Right now it's 28.19. And then we'll measure this angle here. So we'll select our 3 points. We'll go ahead and measure that angle, 151. And as you can see, as I make this angle smaller, that this angle, or this angle smaller here, you can see this angle gets bigger and they kind of move with each other. So again, I'll go ahead and make it really shallow. This gets very big. If I were to instead go the other way and make this angle really big, this angle becomes very shallow. So we can also go ahead and calculate it really quick. So all I'm going to do is I'm going to take this angle here and I'm going to add it to this angle here. And we'll get our calculation. So you can see as I tweak the one, no matter what I do, those two angles add up to 180. We can also investigate one other thing, which if I were to measure these, so I'm going to measure this angle here. So this angle right here, and I'm also going to measure this angle right here. And then I'm going to add these two other interior angles, see if they have any relation to this angle here. So I'll go do one more calculation. Let's go number, calculate, add those two angles together. And we'll see another interesting property. So you see I'm measuring my two opposite interior angles here. I'm adding them together, and oh, it's equal to this exterior angle here. That's kind of odd. Let's see if that always holds true. I'm going to tweak it as these two measurements went bigger. They added up and identically matched this angle here. So we could also say the measure of the two other interior angles is always going to equal the exterior. And I could tweak this no matter what I want to do. These two numbers are always going to be the same. It's just a property of those interior and exterior angles. So we're going to take a look at one more thing. And again, if you want to cover some more material on this, go ahead and reference 6-9 from the book. But we're going to cover one more thing, is that if I have two triangles and they share two identical angles, I know they're similar. So let's just recap really quick. Let's just say I have like a triangle like this, and we'll do our markings. And I've got another triangle like this. I'm going to draw them roughly as similar as I can. That I know these two triangles are similar. And we're going to kind of briefly explore that in Math 10. You'll kind of be able to prove this, but for now, we're just dipping our feet into it. So again, if I have two angles here that are the same, I know that these two triangles are similar, that they're just a scaling of each other. So we're going to take a quick look at this with another program. So I'm going to go ahead and take a look at two triangles that are similar to each other. So this is kind of another simulation model of it, where I can take this white triangle, I can rotate it, I can translate it, and I can also dilate it. I can scale it up and down. So we've kind of made our markers, and we can see that, oh, they're trying to communicate with this, that this angle is equal to this angle. And separately, this angle with two marks is equal in measure to this angle. And so what we're going to do is we can kind of scale our triangle up and down to dilate from the red triangle, and we're going to take a look at this in action. So one, if a triangle always adds up to 180, if you have two sides, let's say like one is 60 and the other is 30, I know the last one's 90. So really, if you've got two angles of a triangle, you also know the third angle of the triangle is pretty much set. And so we're going to prove this just with some kind of geometry transformation. So take this slider, I'll just scale it up to a random length. So again, I've got the two angles equal. Let's see if they're similar. So we'll translate it over. Again, our translations are our slides. We'll match up those vertices together. And let's go ahead and rotate it. And again, if I can translate it and then scale it down, I know they're similar. So I've translated it, I've rotated it. Let's see if it's similar. If I can scale it down to this exactly to the other triangle, I know they're similar. I scale it down, and it is similar. So you'll explore this kind of a little bit more in depth in Math 10, but I just wanted to make sure you guys had kind of your feet wet for it. So again, if I know that two triangles have just two identical angles, I actually know that they all have three identical angles. And if they have three identical angles, well, then they better just be a scaling of one another. So on that, I will see you guys for office hours on Wednesday. So if you have any questions on this, make sure you bring them to office hours, and I will see you later this week. Take care.